We're demonstrating ETC, or Energy Time Curve, from Studio 6 Digital. ETC is available as an in-app purchase in the Audio Tools iOS app. ETC measures audio room decay time graphically by showing the decay of a pulse over time. Typically, you'll make an impulse sound by clapping your hands, popping a balloon, or even snapping your fingers. The graph will show you the decay of the signal over time, and from this, the RT60 will be computed. ETC works great with the internal iOS device microphone, or pair it with our iTest mic for Class 2 results, or use it with our iPrecision mic for Class 1 performance. Let's see how this works. First, we'll select a weighting. We have A, C, and all of the octave bands available. Next, we'll select a time window, in this case 800 milliseconds, which should be plenty of time for the room that we're in. Now we'll tap the play pause icon to arm the display and create an impulsive sound, in this case with a hand clap. You can see the initial peak sound and the decay of sound over time. We can use the cursor to read the exact dB and time delay at any point in the screen, and use the touch GUI to adjust the plot. Using a two-finger swipe gesture to move the cursors over the linear portion of the decay curve, the app calculates the equivalent RT60 time of the decay. This is shown on the purple cursor with the green decay line. Now let's try another frequency band. In this case, the octave 125 Hz band. Since a hand clap would have very little energy in that band, we're dropping a heavy book. Here are the results in that octave band. ETC is a great tool for quickly and accurately measuring the decay time of a room for a single weighting filter. If you are looking for a more powerful and comprehensive tool to characterize the decay of all of the octave and 1/3 octave bands, as well as a number of other parameters, please see the demo video for our impulse response module. IR uses a swept sine signal and deconvolution to analyze room response and compute T20, T30, clarity, signal to noise, definition, and many other results. Let's look at some of the options available in ETC. If you will be creating the impulse sound to trigger the graph, select External Trigger. In External Trigger mode, you can calculate RT60 times but not absolute delay times. Turn External Trigger off if you want to use the internal impulse signal from the iOS device. In this mode, you have to route the audio output of the iPhone to your sound system input. ETC will start the graph from the exact time that the pulse is sent from the iPhone. You can see the time that it takes for the pulse to return to the iPhone from the speaker. Use this to set the relative speaker delay times. The threshold level is used to set the audio level at which the graph will trigger in external mode. It has no effect in internal mode. You can also select the cursor display options as well as the units for the plot, time or distance. Let's see what distance mode looks like on the display. ETC also includes the same powerful save recall system that is used throughout the Audio Tools app. Tap the folder icon to bring up the save recall screen and just enter a file name and tap Store File. The file will be stored locally on Dropbox or iCloud. To recall a file, just select it and tap the recall button. The stored plot will be shown on the screen. This concludes our demonstration of ETC, or Energy Time Curve, by Studio 6 Digital.